I wanted to go over a couple things as we start our new unit here on geologic history and dating stuff, absolutely and relatively. So for today, you're gonna need a couple things. This is the PowerPoint I gave last week, or you can just follow along. Doesn't make a difference. You have a copy of it. You are going to need this thing that says Geosequence Earth Science, which is a slide. And you have your reference table, but I'll also include this to you guys for rock map units. And also, you're going to need this rock sequences that I kind of pulled out last week for you. So again, I just want to go over a couple things. And I know you watched the Ed puzzle last week, and it's pretty good. But again, I just want to touch on some things, and hopefully we're all doing okay. So relative dating, how are we going to be able to date rocks? Again, relatively means how old is it compared to this, or when did it happen compared to that, or which rock layer is older because of whatever reasons, and there's some rules that we need. The first rule is, and you don't have to really know the name of it, but uniformitarianism is the idea that the forces working on our planet today worked on our planet in the past in a similar manner. So you'll hear this phrase once in a while, the present is the key to the past. So if we see erosion happening, faults, earthquakes, volcanic eruptions, tsunamis, everything, you name it that affects the landscape. If we see it happening today, it was happening in the past. So it could be thousands of years ago, millions of years ago, heck, we even go to billions of years ago, that the forces that are on our planet today, reshaping, reworking the landscape, is what we have in the past. So we're able to kind of say what happened in the past. So we're going to try to determine the age of a rock or an event in relation to other events. We're not looking for specific dates. That'd be absolute dating. We'll do that later. So we're just sticking with relative dating. So one of the major ideas or rules is the principle of superposition. Is the idea that the bottom layer is the oldest and each overlying area gets progressively younger. So here is the oldest layer, and as we go up, then that was deposited, then that was deposited, and that was deposited. So as we go up, the rocks get younger. We could also say when we have fossils in here, the fossils down here are older than the fossils that we find up here. Or usually we can say that these organisms were on Earth first compared to what was up here. And we'll touch a little on that here and there as we get to it. Original horizontality, basically that means sedimentary rocks are deposited horizontally. We do not find sedimentary rocks deposited vertically. The only way you get vertical sedimentary rocks is if you have them deposited horizontally and then a tectonic event, maybe like mountain building, also called an orogeny, or some other plate tectonic environment, will actually pick up those horizontal rock layers and turn them vertical. And again, that's why sometimes you'll questions, they'll say, ignore that no overturning has happened to make sure that we have that under our belts. So here's the Grand Canyon. Each one of these layers are sedimentary rocks deposited horizontally, and if they're not horizontal, something probably happened to them tectonically to move them from being horizontal. Extrusion is just molten material that flows on its surface. Okay, that's cool. That's just like a lava flow. Intrusion, when molten rock squeezes into pre-existing rock layers. So that'd be like having two pieces of bread and then you put some jelly in between the two. You squeeze the jelly in there. That would be an igneous intrusion. So the younger the rock that they cross-cut, so anytime you have an igneous intrusion, those rocks have to be there before it can go through them. And that's what that means right there. Yeah, here we have some beautiful rocks. Nice. Here's an example of igneous intrusion sandwiched between two rock layers. Here's another one. I don't know who these kids are. Whoever made the PowerPoint, it's theirs. But nonetheless, it's their kids. Relative dating, contact metamorphism. Ooh, remember Earth Science reference table? We have metamorphic rocks. They're either regional metamorphic rocks, and then you'd contact metamorphic rocks. So contact means when you have an igneous intrusion come through, and actually touching another rock, it bakes the rock into a metamorphic rock. And that is what contact metamorphic rocks are. So you guys should know what this is. And if you don't know what this is, you can always go back to your reference table or look at the handy dandy sheet I'll give you, that is a conglomerate rock. Then we have sandstone, limestone, then we have shale, and then we have siltstone. And we know that this coming through right here is an igneous intrusion. Either you have the sprinkles or you have the V's or the X's that indicates that you have igneous intrusion. So here's an intrusion coming through between two rocks. It actually now, and it's going to bake the rocks it actually comes in contact with. So these little lines right here that are vertical are telling us all within that little area that is contained from here to here, from here to here, all the way through these rocks is contact metamorphic rocks. So what does that mean? So if you have limestone and you bake it and it's contact metamorphic rock, you're going to have marble in this area right here. So contact metamorphism would make that marble. And for shale, we don't have anything, so we'd say that this is a hornfeld. Again, we can look at our earth science reference table. So any area that has a contact metamorphic, remember a hornfeld is a rock that they do not know what the parent rock is, so we could just throw any rock in there and say that it was a hornfeld. But this one we do know contact metamorphism of limestone makes marble. So you have marble along here. Sandstone, this is going to be quartzite, I believe. Could go back and see. I'll look at this. It's been a while right here. Yeah, it's going to be quartzite. And then this would conglomerate be metaconglomerate, I'm assuming, for that one. Have to look at the reference table just to make sure, though. A relative dating fault, a crack in the bedrock where movement has occurred. The younger the rocks, they're younger than the rocks that they cross-cut. So what does that mean? Here's this layer is deposited, then this layer, then this layer, then this layer, then this layer. The beautiful conglomerate right there. They were all deposited, and then you can see there's a fault because they're all offset. And so how do we know that the fault is younger than the rocks? It's because a rock has to be there to break it. You can't break something that's not there. So look at this diagram. These rocks had to be made and then they were broke. So that is one of the last things to happen in this particular diagram. This picture right here. Look at this gorgeous picture right here. This nice beautiful faults all over the place. You can see this white strata or line. Is bent all over the place. So those rocks were all deposited first, and then they're broken up, so the fault was one of the last things to happen here. Man, look at that nice, beautiful area in there. I didn't notice that. It's by a stream. Folds. Folds, thrusting rock layers, pre-existing rock layers, so you can have a plume of magma coming up, and it'll move things and bend them all out of shape and make it all look weird and have them folded. Is a good example. The Black Hills, you have a big thing coming up here, a big magma plume, and bent the rocks all out of place. But nonetheless, you can get folds. And if you take a look right here, these were originally deposited horizontally, and through tectonic forces, you can get these nice bends or mountain building events. Remember, called orogenies. We can get those events happening there. Ignore this one right for now. We're not going to do this correlation. We're going to skip this part. If we were in class, we would definitely do it. But we are skipping all the things that go down along here about what an index fossil is. We'll do dinosaurs and fossils and everything a little bit later. But we are going to skip this bottom part right here, which I asked you not to take notes on. It wasn't in our notes, so we're all good. So cruising back to this right here. So let's go through some examples of what I want you to be doing over the next couple days. I did give you this sheet right here, and these are examples, a lot more in depth than what we need to do, but you can always go back and take a look at them and see what's kind of going on and give them more clues. But I've given you a lot of clues in what we're doing right here. So if I go through right here, I'm going to keep it like this so I can go through the slides and go back and forth. But remember, relatively dating something. We're on slide 2. Relative dating is the determination of the age of rock in relation to an event. So here we have Niagara Falls. If you had a chance to go to Art Park or walk the Niagara Gorge, you would see these rock layers that would be on the other side of the falls. And so you see these nice horizontal rock layers. They have the horizontality there. We have superposition, where this is actually the first layer, old. This is first, that's deposited second, deposited third, fourth, fifth, and then finally sixth in this right here. And they can make a lithostratigraphic column. So here is a drawing of horizontal rock layers. So we know here the Queenston Shale, we have the Whirlpool Sandstone all the way up to Lockport Dolostone. So if you went to Lockport Caves, you went into Lockport Dolostone. They had dolomite here, but if we look at our map units in our Earth Science reference table, it's Dolostone. Potatoes, doesn't make a difference as we go through all these ones. Here's a beautiful example again of horizontality for the Grand Canyon. Here's the bottom of the Grand Canyon called the Vishnu Schist. And then as you go from the schist all the way up to the Kayyab Plateau up here, which is limestone, you have all these beautiful horizontal rock layers, except for this is schist. But nonetheless, you can make a lithostratigraphic column right here and kind of describe what's happening in the Grand Canyon. We're able to figure out what happened first, second, third, without using specific ages. So here's what we are going to be doing. and give some examples for this one. So I'm going to give you where these rock blocks that show different patterns, and you have to come up with what's actually happening and describe what's happening in them. So for this one, for example, in slide 8, I'm going to ask you the name of the rock. You can use your earth science reference table. So C is going to be shale, K is limestone. Here you have sandstone. Here you have shale. They have horizontality. They're all horizontal lines. And we also can apply superposition here. And remember, the key is the present is the key to the past. So is there any folding here? No, I don't see any waves. Is there any faults? Nope, these are all horizontal. I don't see any offsetting. Are there any intrusions? Nope. So the sequence of what happened here is C was deposited first. Then I used, this is not greater than and less than symbols. I don't know how to use an arrow. I don't know the keystroke for this one. That's why I just used this chevron right here. So C, then K was deposited, then S was deposited, and then on top B was deposited. So the last thing to happen in here was rock layer B was deposited. The first thing to happen in all of this relatively was C was deposited in this one right here. In this next one, which I think was your homework from last week, name the rocks. I didn't ask you to name the rocks. I just asked you to do the order that things happened. And look, if it's okay, if you find a thing there's like 10 blanks to fill in and you only have 5, that's fine. Because again, we can't go totally in depth because there's a lot of stuff. We're just kind of getting the main feel for what's happening in our new, the way we're learning right now. So A is limestone, then you have sandstone, then K is going to be, I don't know what happened here, is going to be shale. Maybe hit something there. Oh, is shale. Here you have folding. Is there any folding? Nope. Any faults? Nope. Any intrusions? No. Sequence events. A was deposited. Then M was deposited. Then K was deposited. And then erosion happened. How do we know erosion? Well, we know this would be all the way through. It's probably a stream or a valley or something like that. Maybe think of Letchworth or the Grand Canyon. And the Genesee River cuts through in Letchworth, or the Colorado River cuts through in the Grand Canyon, but nonetheless, erosion is the last thing to happen through here. Looking at our next block, which was, I think, your homework again, I'm asked you to label these for the next couple of these. So P is going to be limestone. Here you have sandstone. Q is going to be shale. Any folding? Nope. Is there faulting? Yes. Here's the fault right here. Any intrusions? No. So what's the sequence of events in here? P was deposited, then S was deposited, then Q was deposited, and then the fault. So the fault cross cuts all of these, and like I said earlier, that the rock has to be there in order to break it. So these rocks had to be deposited and then they were broken, is what's happening in our sequences. This next one right here, S is limestone, you have A for sandstone, you have T for shale. I just randomly picked these letters. Folding, yes. Faults, no. Intrusions, no. So the sequence here was S was deposited, then A was deposited, then T was deposited, and then it was folded, is the order of events right there. This last one right here, I'm going to have you name them again. It says limestone, sandstone, and then finally shale. And then this one right here is going to be our intrusion. Again, how do we know it's our intrusion? Sprinkles, V's, or X's. Is there folding? No. Faulting? No. Intrusions? Yes. Sequence of events from oldest to youngest, so Z, then Q, A, and then finally C came through. So C cross cuts all of them. And not only does it cross cut all of them, you have contact metamorphism all along this interface between this intrusion and the bedrock right here. So here you have marble in this area, you have quartzite in this area, you have hornfelds right here. Same on the other side. And again, you look into your reference table for contact metamorphism to see what's happening there. So what this rest of this assignment or PowerPoint is going to be, and please read the directions. I'm going to tell you what slide numbers to do. So for example, 13, 14, so on and so forth. And you're going to go through them and come up with a sequence of events for each one of these. Really quick, I just want to point out that for some of these, they don't have the chevrons, the sprinkles, or whatever, but these empty blank ones are going to be igneous rocks, granite, or intrusions. And then we should be able to know that by now being earth science, because I just went over how this is contact metamorphism, because it's baking the rocks. And we see that in a bunch of samples all over the place. These will get progressively easier, more difficult, and then you get easier and difficult kind of all over the place. Again, we're practicing our skills. So you might run into some problems. That's cool. Remember, you can always stop, look at the video over again, or check out other resources, or do whatever you need to do. But I will be giving the answers for these. There's nothing to do with 22. But nonetheless, again, you see they kind of get all over the place in terms of their complexity for that one. And then at the end of the day, I'll give it two doozies right here to figure out. But again, we'll slowly get through this whole week. So please make sure you pay attention and look at the directions and kind of lay it out for you. You will be getting the answers to these things. And I will be going over these verbally, so you get any questions. You can stop, watch the video over again, or if you have a question, please ask in Google Classroom in the public comment, because somebody else might have the same question as you for that one. So I will post some other videos and see what's going on. So any questions, again, feel free to hit me up through Google Classroom. Otherwise, be safe, take it easy, stay 6 feet apart, and I'll talk to you later.